in this 89 question, there is no identification, all right? You only have to calculate what they ask you to do. So you just do it one by one, all right? So first of all, we find the length of AB prime and AC prime. AB prime and AC prime are these vertical stretches. These are lengths on the shadow, right? This is AC prime in orange. This is AB prime in green, all right? So you can use the right angle triangle to help you find this, all right? Say, for example, the orange one, all right? You can have this right angle triangle, ACC prime. This is ACC prime, all right? And you have the blue angle here is 30 degrees. And this is 10, this is a right angle. So you have 1, 2, 3 pieces of information. So it's not difficult to get AC prime, all right? The answer for this one, AB prime, according to my calculation, will be 7.07, all right? And AC prime will be 8.66 to 3 significant figures, all right? Okay. All right, and likewise, we can do BC, right? BC will be just the right angle triangle, the hypotenuse of the right angle triangle, that is BC. All right, we have the 10 and the 10 here. Once again, 3 pieces of information. All right, that is the triangular cardboard. So BC will be the square root of 200, and that goes to 14.1, all right, for BC. All right, it is the square root of 200. And then for BB prime and CC prime, these are the vertical parts. All right, the yellow part here. All right, that is the yellow part here. All right. So once again, you can do it in the same right angle triangle. All right. So CC prime is 5. This is an exact value. All right. This is 707 for BB prime. All right. All right. So almost all of us, we are okay at this. All right. But the problem comes in part C. Part C is the difficult one, right? We want to find the B prime, C prime. We want to find the line at the ground level, all right? The length of the shadow at the ground level. So if you look at this, it is a trapezium, isn't it? If you look at this, right? I want to use color code to indicate the lines, all right? If I code them in color, so you see, and the bottom, I'm running out of colors, right? Let me use this one, right? As the bottom. So that would be this one, all right? That is B, C, C prime, and B prime. And these two, they are right angles. We know that this BC is 14.1, all right? It's in fact 14.1 something, right? 14 something, all right? If you want more accuracy, all right? And then the CC prime will be 5. And then the purple one over there is 7.07107, something like this. All right. So in fact, we want to find the baseline B prime, C prime from the rectangle. All right. So there is where some of us fail in part C. All right. Now the proper way to do that is to split the right angle, split the trapezium into a rectangle and a right angle triangle. That is the proper way to do that. All right. If you split the right angle here, so that there is a rectangle, we know that in the rectangle, the two baselines, they have the same length. This is also the same length. All right. So we can use the Pythagoras theorem to get this. So this purple part will be shortened to 2.07 because it's 7 minus 5. All right, we have the 5 here. So you subtract the 5, you are going down to 2.07 for this purple part. So you can use Pythagoras theorem to get this B prime, C prime, all right? So the flow is like that. So at the end, I'll leave the calculation to you, right? I'll only brief you the procedure. So to this end, the answer to B prime, C prime is 13.98966, all right? Round to 3, that's a significant figure. It goes to 14.0. That is the answer of B prime, C prime, all right? quite a lot of us fail to meet this B prime, C prime. And the process is like this, right? Look at these arrows. First, we realize this is a trapezium, right? The first thing we realize it is a trapezium. The second thing, to handle a trapezium, we cut off a part of right angle triangle and a rectangle. So in the right angle triangle, we can use Pythagoras theorem to get the purple line. And with a rectangle, we can get the purple line downwards, all right? So it is the same line, all right? So that's how we do this, all right? If you fail, maybe in the accuracy, maybe if you have answers like 13.9, then I think you know how to do it, but you fail in the accuracy. Otherwise, you're good, all right? And then for part D, now once you have all three lines, you have the orange line, all right, in A prime, in AC prime, you have the green line in AB prime. Now you have this violet line, all right, B prime, C prime. So you have all three lines. You can use Heron's formula to get the area, isn't it? AC prime is 8.66 and AB prime is 7.07 something, all right? And then B prime, C prime, we just did the calculation, is 19 point something, all right? So we can use Heron's formula to get the area of the shadow. And also we can use triple S cosine formula to get the angle of B prime AC prime, because we are talking about this angle, not A prime, but A, all right? We can use triple S cosine formula, and the answer to this one, to the nearest degree, is 125 degrees, all right? The area of the shadow, we can use Heron's formula, and that is 25 meters squared, all right? So this is it, all right? This is it. I think it's pretty good. It's much better than the previous time, as long as there's no identification involved. It's only calculation. But I believe some of us fail at part C, that should fail to realize how to handle a trapezium, all right? For those who manage to get part C, and then you will get part D for most of us, all right? The only problem will once again be accuracy problem, all right? We can deal with accuracy later, all right? But now I see, right? If there's no identification problem, if it is only calculation, I would say most of us are quite good at the calculation, all right? So next time, when I design the thing, I would mainly focus on how to do the identification, all right? And perhaps something else. All right, so this is it, all right? Let me see if there's any problem. If not, we can call it a day. All right, now remember, during the Easter holiday, you have to catch up on the Edmodo, some of the video that you have missed. All right, and when we come back after the Easter holiday, we will have two tests, one on probability and combination, one on 2D, 3D problem. There will be another form test. I don't know what is the content of the form test right now, but we shall see, all right? I'll post the update on the Edmodo on the Edmodo classroom so that you can follow up the updates, okay? So we'll finish today on time. It's 9:20, okay? All right, so see you after the holiday. Bye-bye.